On today's episode, why fuses are still the ultimate in circuit protection. This episode is brought to you by engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.com TV today. This is a fuse. Now this is an ATO type commonly seen in the auto industry, although it's being replaced with smaller equivalents today. If you drive too much current through a circuit, any circuit, it'll generate heat. Now as long as the overcurrent condition exists, that heat will build until something fails. At the dawn of the age of electricity, before 1900, there was a simple way to prevent things from burning up. Let something intentionally burn up. Now, inserting a short segment of small gauge wire into a circuit created an intentional weak point, containing the damaging effects of overcurrent to a controlled, safe location. Fuses became industry standard until the advent of circuit breakers decades later. It was the second most well-understood electrical device on the planet after the light bulb. When the lights went out, you checked the fuses. If it was burned out, you could see it visually, and replacement was generally something you didn't need an electrician to do. Now this particular fuse protected a 24-volt AC circuit that energizes the coil on a single-pole double-throw contactor that controls current to an air conditioning compressor. Now contactors themselves were an innovation, allowing safe, low-cost, low-voltage control currents to manage distinctly unsafe, high-voltage, high-power circuits. Now this 50-cent device protects an expensive control board, and just as importantly, its failure is both visible to the naked eye and testable because the blade contacts are exposed at the top of the circuit for testing. Now would a circuit breaker be better? It would certainly be easier to reset than replacing this fuse, but it has several disadvantages. It's more complex, more expensive, and is itself a potential point of failure. Its very convenience makes it possible to ignore transients or occasional shorts by resetting at the push of a button, which is not exactly conducive to good MRO. If you want to get really sophisticated, we could control current with something like an SCR and a microcontroller using current sensing feedback loops to throttle the current as necessary. Now on this home HVAC application, that could make that $400 control board a $1,000 board. And since that 24-volt thermostat power transformer fails approximately once every 20 years, there's a real chance that the protective devices could fail before the device they're intended to protect. Now fuses are good because they're simple and cheap. So why am I talking about this? Well, because the increasing prevalence of processor-controlled devices and the increasing reliability of those devices is starting to shift focus from complex system failures back to simpler, traditional ones in both consumer and industrial equipment. A couple of decades ago, I would instinctively suspect an 8088 processor in a motherboard as the culprit in an automation application, for example. With today's much more sophisticated systems, however, a semiconductor power device or a short circuit or open ground are far more likely to cause a circuit failure. Now, this doesn't require a PhD to cope with. And for anything over about 5 amps, these devices make troubleshooting literally a snap. I hope they never go away. Well, that's it for today's episode of End of the Line, brought to you by engineering.com. If you like this show, be sure to subscribe to our channel and click on the notification bell for our next episode. For our deeper engineering video series for the manufacturing professional, visit engineering.com TV to watch exclusive shows like Manufacturing the Future, not found here on our YouTube channel. The link is in the description below. Thanks for watching.